Hello everyone! We are here today to discuss our ongoing research project that seeks to evolve architectural design by integrating born and built environments to sustainably address social and economic challenges. We utilize Generative Design Processes, or GDP, in conjunction with emerging artificial intelligence technologies to merge traditional methods with innovative approaches.
Our research is grounded in the concept of generative design, a paradigm that leverages computational algorithms and AI to create innovative, biomimetic architectural design solutions. This approach is particularly relevant in the context of contemporary societies, which are grappling with complex challenges such as rapid urbanization, environmental degradation, climate change. Additionally, there is a growing concern about the degradation of physical and mental health, with the intensification of problems like isolation, depression, obesity, and cardiovascular issues.
We have developed a generative architectural design approach that leverages the computational algorithms and AI to create innovative design solutions. These solutions address complex challenges faced by contemporary societies, such as the use of scarce materials, high energy consumption materials, and high CO2 emissions in their processing. The concept of biophilic and biomimetic architectural design embodies proactive environmental stewardship, encouraging us to view environmental management as an integral part of our lives. This is not about conserving the environment as it is, but rather managing it in a way that we can coexist symbiotically in the long term. The potential of AI in architectural design has been explored, starting to demonstrate its effectiveness in optimizing design solutions.
Drawing on principles from environmental and developmental psychology, our research promotes human well-being through biophilic design. This involves understanding how individuals interact with their physical environment and how it influences their behavior and development. The concept of biophilic and biomimetic architectural design embodies proactive environmental stewardship, encouraging us to view environmental conservation as an integral part of our lives.
The challenges our research aims to address are particularly significant in regions with a temperate Mediterranean climate, where land abandonment and forest fires pose significant problems. However, our approach also benefits other climates, as it aims to thermally stabilize buildings in extreme conditions simply by thermal inertia. Furthermore, the consumption of materials is minimized by using local mass from the biome.
Our research provides solutions for these issues, enhancing the sustainability of these regions and the well-being of their inhabitants. A key aspect of our research is the integration of ancient earth sheltering techniques with AI in the design process. This method uses Earth's natural insulation and thermal mass to protect a building from outdoor temperature extremes, precipitation, wind, and humidity.
We have developed a computational model of Gaudí's stereofunicular, which is used in the generative programming of compressed earth building systems. GDP, Generative Design Process, simulates the dynamic evolution of shapes across various contexts, viewing each design step as a transformation from one form to another.
Furthermore, our research delves into the complex relationship between individuals and their physical environment. It explores how this interaction shapes their behavior and development. This understanding is crucial in our design process, as it helps us create built environments that not only enhance sustainability but also foster human well-being.
Our research supports the hypothesis that integrating artificial intelligence and generative design processes can lead to more sustainable and harmonious built environments. This is achieved by adapting the use of materials and technologies to local conditions. We utilize a variety of materials such as earth, wood, clay, low CO2 emission cement, and recycled plastics. Additionally, we incorporate both ancestral manufacturing methods and cutting-edge technologies in a collaborative man-machine process or even fully robotized systems. This approach allows us to create innovative and sustainable architectural solutions that are in harmony with their surroundings.
The developed GDPs have showcased the possibility of crafting innovative and sustainable architectural solutions to tackle the multifaceted challenges of our contemporary societies. However, the assessment of these generative forms of growth presents a complex task due to their systematic nature, the multitude of factors involved, and the numerous unknown externalities. The power of AI lies in its ability to handle vast variables, enabling us to navigate this complexity and unlock new possibilities in architectural design.
We have emphasized the importance of bridging the gap between humans and natural environments. By incorporating methodologies of biophilic and biomimetic design, we underscore the role of architecture in fostering harmonious relationship between humans and nature. Moreover, our research has addressed environmental challenges in specific regions and fostered a transition towards a climate-neutral society.
Lastly, our research, drawing from environmental and developmental psychology, has been instrumental in shaping a design process that puts humans at the center of sustainable architectural design. This human-centered approach ensures that the built environments we create are not just sustainable, but also conducive to the well-being and development of the people who inhabit them.
In conclusion, our research evolves in the field of architectural design, aligning with the environmental and socioeconomic methodologies. It underscores the potential of integrating artificial intelligence and generative design processes in architectural design.
In essence, biophilic and biomimetic architectural design advocate for a shift in mindset, from reactive environmentalism driven by fear of catastrophe to proactive environmentalism stewardship, motivated by a deep-seated respect for all life and a commitment to sustainable living.
Well, this is it. Thank you for joining us today. We look forward to sharing more about this research in the near future.
We hope you find it informative and insightful. Thank you for your time and thank you for your attention.
Thank you. Bye.